Beneath the stunning geysers and vibrant hot springs of Yellowstone National Park lies a geological giant, a supervolcano with the power to reshape our world. For decades, it has captivated scientists and the public alike, a sleeping behemoth that occasionally stirs. But what if the signs of its restlessness are becoming more frequent, more pronounced? Today, we're diving deep into the heart of Yellowstone to uncover the hidden signals, analyze the latest data, and ask the crucial question: are we prepared for what might be coming? Yellowstone is one of the most seismically active areas in the United States, experiencing thousands of earthquakes every year. Most of these are too small for us to even feel, but they provide a constant stream of data for geologists. Think of it like a patient's heartbeat on a monitor. A steady, predictable rhythm is normal. But what happens when that rhythm changes? Recently, scientists have been paying close attention to earthquake swarms. These are clusters of small quakes occurring in a short period in a specific area. These swarms can indicate the movement of magma, water, or gas deep beneath the surface. While they're a common feature at Yellowstone and don't automatically signal an eruption, an increase in their frequency, depth, or intensity could be a significant warning. The data from the University of Utah seismograph stations, which monitor the park, is absolutely crucial. They're looking for patterns, for any deviation from the norm that might suggest something new is happening in the volcano's complex plumbing system. It's a subtle language, but one we must learn to understand. Then there's the ground itself. Yellowstone breathes. The land surface rises and falls as the magma chamber below fills and empties, a process that can take decades or even centuries. Using GPS instruments and satellite radar, scientists can measure these movements with incredible precision, down to the millimeter. Between 2004 and 2010, the caldera floor rose at an unusually high rate, faster than any time since measurements began. This caused quite a stir in the scientific community. While the uplift has since slowed and even reversed in some areas, this period of rapid inflation was a powerful reminder of the dynamic forces at play. Any new, sustained, or unusually rapid ground deformation is a primary indicator that scientists are on high alert for. It's like watching a balloon inflate. You know there's pressure building inside. The key is to determine how much pressure is building and how close the system is to its breaking point. Let's not forget the park's most famous features, its geysers and hot springs. They are the surface expressions of the immense heat engine below. Changes in their behavior can be another vital clue. Imagine Old Faithful suddenly changing its eruption schedule, or a familiar hot spring drying up while a new one appears elsewhere. These aren't just tourist attractions. They are direct vents for the volcano's heat and pressure. Scientists monitor the temperature, water chemistry, and gas emissions from these hydrothermal features. An increase in the output of volcanic gases like carbon dioxide and sulfur dioxide, or changes in the chemical composition of the water, could signal that fresh magma is rising closer to the surface, heating the system from below. One of the most famous examples is the Steamboat Geyser, the world's tallest active geyser. After decades of relative quiet, it reawakened in 2018 and has been erupting with unprecedented frequency. Is this just a normal cycle for a complex geyser, or is it part of a larger pattern of change across the entire volcanic system? That's the multi-million-dollar question. So, with all these potential signals, earthquake swarms, ground deformation, and changes in geyser activity, what does the latest data actually tell us? The Yellowstone Volcano Observatory, a consortium of scientific agencies led by the USGS, provides real-time monitoring and regular updates. Their current assessment is that the volcano is at a normal background level. The recent earthquake swarms, ground movements, and changes in geyser activity are all considered within the realm of normal behavior for such a large and active caldera system. They emphasize that for an eruption to be imminent, we would need to see a dramatic combination of these signals, happening simultaneously and increasing in intensity over weeks or months. For instance, we'd expect to see intense earthquake swarms getting shallower and shallower, rapid ground deformation of meters instead of centimeters, and massive changes in gas emissions across the caldera. We're not seeing that now. This brings us to the core of the issue: preparedness. While a cataclysmic supereruption in our lifetime is extremely unlikely, the possibility exists. The last one was 631,000 years ago. And geologically speaking, the volcano is not overdue. Volcanoes don't operate on a fixed schedule. However, a much more likely scenario is a smaller but still highly disruptive hydrothermal explosion or a lava flow. A hydrothermal explosion happens when superheated water flashes to steam, creating a crater. These have happened at Yellowstone in the relatively recent past. A lava flow, while less explosive than a supereruption, could still have a significant impact on the park and surrounding areas. Federal, state, and local agencies have response plans in place. The USGS has a clear framework for communicating volcanic threats, using a color-coded alert system to keep the public informed without causing undue panic. But preparedness goes beyond government plans. It's about public understanding and education. Sensationalized headlines often paint a picture of imminent doom, which isn't helpful. The real story is one of careful, constant scientific monitoring. The work being done at Yellowstone is a marvel of modern geology. The thousands of sensors, the satellite data, and the dedicated teams of scientists are our eyes and ears on the ground. They are our early warning system. What can we take away from all this? First, Yellowstone is an active volcano, and it will erupt again someday. That someday could be thousands of years from now. Second, the signs of an impending eruption would be strong, widespread, and unmistakable to the scientists monitoring it 24/7. We wouldn't be left guessing. The subtle signals we see today, the small earthquake swarms, the gentle breathing of the ground are signs of a living, breathing volcano, not necessarily a dying one about to explode. They are the background noise of a geological giant. So instead of fearing Yellowstone, we should appreciate it for the incredible natural laboratory it is. The research here helps us understand volcanic processes all over the world. By supporting this science and staying informed through reliable sources like the USGS, we can replace fear with fascination and anxiety with awareness. The story of Yellowstone is not one of impending doom, but of a dynamic planet and our ever-improving ability to understand its powerful forces. Thank you for joining me on this deep dive into the heart of Yellowstone. If you found this exploration fascinating, don't forget to like, subscribe, and hit that notification bell so you won't miss our next adventure into the wonders and mysteries of our world. Stay curious.